Section 11.3.19. A random sample of 40 adults with no children under the age of 18 years result in a mean daily leisure time of 5.55 hours, with a standard deviation of 2.56 hours. A random sample of 40 adults with children under the age of 18 results in a mean daily leisure time of 4.61 hours, with a standard deviation of 2.01 hours. We're going to construct and interpret a 95% confidence interval for the mean difference in leisure time between adults with no children and adults with children, meaning population 1 mean minus population 2 mean. Okay, so first thing is first. Okay, we need to determine what does population mean 1 represent. So what we're going to do is we're going to go ahead and identify that. So we're going to let population mean 1 represent the mean leisure hours of adults with no children under the age of 18. So that is the first sentence with 40 adults with no children under the age of 18 years that has a mean daily leisure time of 5.55 hours and a standard deviation of 2.56 hours. And then population mean 2 represents the mean leisure hours of adults with children under the age of 18. So we have 40 adults with children under the age of 18 with a mean daily leisure time of 4.61 hours and a standard deviation of 2.01 hours. So again, we want to be able to construct a 95% confidence interval. Now, the difference between two population means, population mean 1 and 2, with unknown population standard deviations, approximately follows the student's t distribution because the unknown population standard deviation is unknown. If the following assumptions are met, the samples must be simple random samples, which they are, the samples must be independent, which they are, and the populations must be normally distributed, or the sample sizes must be large, meaning greater than or equal to 30. Well, the sample sizes are 40, therefore it's greater than or equal to 30. Now recall that if the confidence interval does not contain 0, conclude that there is sufficient evidence to reject the null. Otherwise, there is insufficient evidence to reject the null. So, before we use StatCrunch, we want to be able to identify the following. We want to find out what is the mean from the problem of population 1, what is the sample standard deviation of population 1, and what is the sample size of population 1. Well, we can see here that the mean is 5.5 hours. We know the standard deviation is 2.56, and the sample size is 40. We want to be able to find the mean of population 2, standard deviation of population 2, and the sample size for population 2. We know that the mean is 4.61. We know the standard deviation is 2.01. And we know the sample size is 40. Okay, so now what we want to do is we're going to enter the data into StatCrunch. Okay, now, if we had data where we'd have to put these in columns, if we had more than, a particular number, in this case we're given the mean, we would put our information in columns, but we don't have data, we have stats. So therefore, since we have stats, we're going to then go to stat directly. We're going to scroll all the way down to t-stats, and then we're going to go to toSample, and we're going to highlight with summary because that's what we have. We have the summary information, not the data. So we're going to select with summary, and we're going to put the sample mean to be 5.55. We have the sample standard deviation of 2.56 for population 1, and the sample size is 40. Also, we know the sample mean for population 2 is 4.61. We know the sample standard deviation is 2.01. And we know the sample size is 40. Make sure the pool variances is unchecked. We don't want to perform the hypothesis test. We want to perform the confidence interval for when it's 0.95. Okay, now that we have that information, now we can go ahead and then select compute. So I'm going to go ahead and copy this information. So you can see here from our information, we can now determine what is our lower limit and what is our upper limit for our confidence interval. Well, here we can see that our lower limit, we can round it to 2 decimal places, gives us negative 0.09. Okay, and then the upper limit, rounded to 2 decimal places, is 1.97. Okay, now when you're using technology, whether it is the calculator or StatCrunch, the degrees of freedom is going to be different than when you're doing it by hand. So these numbers could be very, very close to when you're doing it by hand. And if you put this answer into my stat lab, it's still going to take those results because it takes it at an error of plus or minus 0.02 of a particular number here. So in this case here, this is our confidence interval. Okay, now what we need to do is we now need to form a conclusion. And recall that, do we know if 0 is in this interval? Well, we can see this goes from negative 0.09 to positive 1.97, which means that 0 is in that interval. So now we can go ahead and then state the following. Recall that if the confidence interval does not contain 0, which it does, you conclude that there is sufficient evidence to reject the null, and conclude that there is a significant difference in leisure time between adults with no children and adults with children. Otherwise, there is insufficient evidence to reject the null. So conclude that there is a significant difference in leisure time between adults with no children and adults with children. In this case here, there is 95% confidence that the difference of the means is in the interval because we know that 0 is in there. So we would say that the 95% confidence interval for population mean 1 minus population mean 2 is the range from negative 0.09 hours to 1.97 hours.